This is the video 4 of MEKG video series. In this video, propulsion transmission system topics are discussed. Topic 1: Components of a transmission system.
You are looking at the transmission system used in ships. The shafting system connects main engine flywheel to propeller, independent or integral thrust block, intermediate shaft, and propeller shaft. The length of the shaft depends on the location of the main engine. The thrust block transfers a head or a stern thrust to the hull. A thrust block is an independent or integral thrust block. The thrust block limits axial movement of the shaft. The thrust shaft connects main engine flywheel and intermediate shaft. The intermediate shaft connects the thrust shaft and the propeller shaft. The shaft load is taken by the intermediate bearings. The shaft cannot work efficiently without proper lubrication and support of bearings. The propeller shaft connects the intermediate shaft and the propeller. Stern tube bearings hold the portion of the propeller shaft extending outwards. Stern tube holds the stern tube bearings. The stern tube can either be oil lubricated or seawater lubricated. Stern frame provides support to the stern bearing, overhung shaft, and heavy propeller mass. The propeller is connected to propeller shaft. The main engine drives the propeller. The propeller rotation exerts a thrust on the thrust block, transmitting an equal reaction to the hull. Main engine flywheel, thrust shaft, intermediate shaft, and propeller shaft are joined together by couplings. Each coupling is held together by bolts. Shafts are machined all over and the bearings have a smooth finish.
Topic 2: Types of coupling. Topic 3: Bearing load method.
The shaft alignment of a ship is checked by assessing the bearing loads using hydraulic jacks. Correct alignment of the shaft allows the bearing to take equal loads of the shaft. Hydraulic jacks are placed on each side of the shaft bearing to lift the shaft clear off the bearing surface. Top keep bolts are slackened to allow the shaft to move upwards. A dial gauge fixed to the bearing indicates lift. The jacks exert hydraulic pressure. Reading on the pressure gauge indicates load on the bearing. Lift and load readings are plotted on a graph using the pressure gauge and dial gauge values. The curve on the graph takes a different shape as the shaft lifts. Change in shape of the curve indicates that the shaft is free from the bearings and that the jacks bear the load. This load is ascertained from the graph. The load for all the shaft bearings are measured and compared with the design values.
Topic 4: Working principle of a thrust block.
The propeller provides the thrust for the ship's movement. The animation shows a right-handed propeller that rotates clockwise and pushes the water behind it, in creating a thrust on the ship's hull to move it forward in the ahead direction. If the direction of rotation is reversed, the propeller generates a thrust in the opposite direction, and the ship moves in a stern direction. The propeller blades are set at an angle. Among other things, the after-end design of the ship, the velocity of the incoming water into the propeller blades, and the eddies around the vessel affects the propeller efficiency. The shape of the blade is like an aerofoil, which increases the velocity of water at the top of the blade. This reduces the pressure at the back and exerts a greater pressure on the front face of the propeller. This pressure difference generates a force perpendicular to the blade. The axial component of the force exerts a thrust on the propeller shaft. Thrust block mounted on the shaft transmits the thrust to the ship's hull.
Topic 5 Operations of a thrust block.
The casing of the independent thrust block is in two halves, and fitted bolts join the halves. Thrust pads, which pivot around the thrust collar surface, carry the thrust load. The pads are mounted in holders and coated with white metal. An oil deflector deflects the oil lifted by the thrust collar and directs the oil onto the top cover. Oil from the top cover cascades over the thrust pads, bearings, and falls back into the sump. The top cover acts as a pad stop. The thrust shaft transmits the thrust onto the thrust collar. Hydrodynamic fluid film wedge separates the thrust pads and thrust collar. The thrust pad transmits thrust to the lower half of the casing. The lower half of the casing is connected to the ship's hull. The ship moves when the thrust is transmitted to the ship's hull.
Topic 6 Thrust bearing.
Insert a feeler gauge in the wear groove on the foremost side of the thrust collar. In the feeler gauge of 0.1 mm is not able to enter the wear groove, the thrust bearing must be overhauled. Remove the lubricating oil pipe from the bearing. Remove the protective shield and the lubricating oil pipe. Remove the lubricating oil pipe. Mount the crossbar. Remove the top half of thrust bearing using hydraulic jack. Remove the protective shields from the thrust collar. Remove the stops from the chain drive above the segments using hydraulic jack and take it out. Suspend a tackle from the crossbar above the segments, which are to be removed. Mount the segment tool on the chain wheel. Turn the segments by turning the engine and remove the segments from the chain casing. After checking the segments, land the segments on the journal and remove the eye bolt from the segment. Turn the engine a little and land the next segments. Repeat the process until all the segments are mounted. After the last segment is mounted, turn the segment tool up and dismount it. Mount it back in the reverse order sequence.